Okay, hello students. My name is Kamulegeya. I'm a teacher of chemistry. Today I'm here to discuss to you what we understand as introduction to balancing chemical equations, as you can see on the blackboard. This concept here is very important in chemistry and it will be of good use in years to come. My dear students, I urge you to pay more extra attention so that you can understand how to balance a chemical equation from scratch. Here, let's start by understanding what we call a balanced equation. Okay, we know that a balanced equation has the same number of each type of atom on both sides of an equation. Now, for us in chemistry, we term something to be a balanced equation if it has the same number of atoms on both sides of the equation. Now, an equation has two sides. It has the reactant side and the product side. For us, our main concern is to make sure the number of atoms on the reactant side is the same as the number of atoms on the product side. Let's take a look and see what I mean by saying the different sides of an equation. For example, if I have hydrogen gas and chlorine gas, these two they combine to make hydrochloric acid. Now, you are seeing I have my hydrogen gas is combining with chlorine gas to give us hydrochloric acid. Now, here you need to understand. In this equation, we have hydrogen gas and chlorine gas. These two terms, we call them the reactants. Whereas hydrochloric acid, we call it the product. Now, what I can best explain what we call reactant. The things we mix to get something. Take an example. When you get hot water, this hot water, you get your tea leaves and get your sugar. When you mix hot water, tea leaves and sugar, what you get is going to be tea. It's going to be what? Tea. The same thing here. If you get that same concept here, you bring it here, you get your hydrogen gas, and then you mix it with chlorine gas. Then what you're going to get here is going to be the hydrochloric acid. Meaning that hydrogen and chlorine, they are the reactants. They are the things you mix so that you can get hydrochloric acid as the product. The same thing there, you get sugar, water, and tea leaves, they are the reactants. When you mix them, you get tea. Tea is the product of the other things you have mixed. The same concept here. Now in this case, to balance in an equation, we need to make sure the number of hydrogen this side is the same as hydrogen this side. The number of chlorine this side, the same as chlorine this side. That's going to be our main concern today in this lecture. So we can understand and see how it works. Yes, what I've written on the blackboard is what we call a word equation. This word equation, I can convert it into a formula equation which I can balance. Take an example. I can convert by writing the respective formulas of each element I've written here. Look, if I get hydrogen is going to be H2 because it is a gas, but hydrogen atom is H. But since it is a gas, it is a molecule, it becomes H2 plus. Chlorine, it is Cl. Because it is a gas, it is Cl2. They combine to give me HCl. give me HCl. In this case, hydrogen plus chlorine give me HCl. Now, in this video, I want to make things very basic, very simple, so that you can understand. By doing that, I may not be so much specific and particular by putting the states of each of the element. My main concern here in this video is to make you understand how to balance an equation. Since it is starting point, we shall keep developing as we go on in different videos. Now here I have hydrogen plus chlorine plus hydrogen chloride. What's happening really? Because we need to understand and see what causes, what should we do when you're really doing the balancing. Then make the visual part of this thing so that we can visualize and see what really takes place in this equation. If you look here, hydrogen, meaning that we have two hydrogen atoms. Let me draw the two hydrogen atoms. There are those ones. Chlorine, we have two chlorine atoms, Cl, Cl. And also we have HCl. HCl is going to be H and Cl. If you are very visible enough, you have seen that here we have two hydrogens, whereas here we have one hydrogen. Are you seeing that? Here we have two Cls, whereas here we have one Cl. Meaning that this equation is not balanced. Since our definition was saying a balanced equation has the same number of each type of atoms on both sides of the equation, we have to make sure that the hydrogen this side, they are the same as the hydrogen this side. Also make sure that the chlorine this side, they are the same as the chlorine this side. If that thing has not happened, then our equation is not balanced. Then, since we say balancing equation, it's like a puzzle. You think of a number which you can add there so that you can balance the equation. Look, in this case, if I add more HCl here, you see, if I try to add more HCl here, meaning that I have now two hydrogens, which makes this one to be 2, meaning that hydrogen is balancing. You are having two HCl's, meaning that here I have two HCl's, meaning that HCl is balancing. Implying that to balance this equation, I need to add the 2 here, so that to make these ones 2, and my equation becomes balanced, because you are seeing we have two HCl's, one HCl, the second HCl, there are 2. I put a 2 here. That's why I can balance my equation. I can write this thing in this way by saying hydrogen plus HCl is going to give us HCl. I put a 2 to balance it. By doing this, I've balanced my equation. My equation is balancing because the number of hydrogen this side, they're the same as the number of hydrogen the other side. Also, the number of HCl this side, they're the same as the number of HCl the other side. Implying that balancing equation is like a puzzle. We just want to balance things to make sure the product, something, the element is this side, is the same as the element the other side. By doing that, you have balanced what we call an equation. Let me give you a few minutes so that you can analyze this thing, so that we can go to our next example. Okay. Okay, well. I think you have understood the way you have done this one. Let's go to example 2 so that we can understand it more and learn how to understand this equation more into detail. Okay, let's go to example 2. Example 2 is going to be, we are going to react, if I react hydrogen and oxygen combine to make water. Okay, we know very well when I get hydrogen plus oxygen, I combine it to get water. In this case, Let me start by writing the formulas of the formula of hydrogen, the formula of oxygen, and the formula of water, so that I can change my equation from the word equation into the formula equation. Is it okay? Yes, you look. The formula of hydrogen gas, it has to be gas. Hydrogen gas and oxygen gas. It's going to be hydrogen H2 plus oxygen gas O2 giving us water. We are saying hydrogen plus oxygen giving us water. Since in my equation I want to make it so basic, I won't put the states of matter in this case. We shall put the states of matter when we proceed with further examples. It's going to be hydrogen plus oxygen giving us water. Now, in this case, let's visualize and understand and see how many atoms are there. If you look here, hydrogen, it is H2. You have 2 hydrogens. Oxygen is O2, which is O. You have 2 oxygens. And also water, it is H2. No, it is OH, meaning that we have 2 hydrogens and 1 oxygen. If you look at that thing visually, we are saying that we have 2 hydrogens here and 2 hydrogens, meaning that hydrogen is balancing in this case. When you come to oxygen, 2 oxygens, and last year we have 1 oxygen. Oxygen is not balancing. Now, I need to get ways. I can make sure that the number of oxygen this side is the same as oxygen the other side. That's the trick behind. That's what we need to do. In this case, I'll add more water here. Look, if I add more water here, I'll add something like this. I'll add hydrogen or hydrogen. Meaning that I've added more water here, implying that I have 2 oxygens, and here you get 2 oxygens. Oxygen is balancing. But if you are very critical enough and you observe, you are seeing that now we have 4 hydrogens. 1, 2, 3, 4. Whereas here now there are 2, meaning that the number of hydrogen has changed. And I need to make it balanced also. What I do, I add more hydrogen here, more hydrogen gas, meaning that it comes to 1, 2, 3, 4. That's 4 hydrogens, and also this side 1, 2, 3, 4. 4 hydrogens. Hydrogen is balancing, and also oxygen 1, 2, 1, 2. Oxygen is balancing. By doing that, I have balanced my equation, meaning that here I have 2 hydrogens. I have to put it to here. Is it okay? And also here I have 1, I don't add anything there. Here I have 2 waters, I add it to here to make it balanced. Meaning that my balanced equation is going to be H2 plus, or this is a 2, giving us 2H2O. That's my balanced equation. These are 2 times 2, that's 4, plus 2 times 2, that's 4. These are 2 oxygens, 2 times 1, that's 2. Meaning that my equation is balanced. I have tried to balance all the atoms on both sides. By doing that, my thing is a balanced equation. Is it okay? Let me hope we are on the same page. We are getting this concept from the basics. Alright. But there are some challenging part which comes in. One time, the student asked me a question. Teacher, you are telling us that you want us to make the number of atoms balancing. But if you look at my equation here, they want us to balance it. Let me rub off this. Let me hope you have understood it. Let me take it off so that we can have ample space and we balance this thing the other way. Okay, one time, a student, you may be there asking yourself, teacher, you are telling us that you want us to balance our equation to make sure that the number of atoms on both sides, they are the same. What if for me, since I have H2, O2, I just put my 2 here so that I balance my equation in the easy way. Because if I put a 2 here, meaning that these are 2 hydrogens, these are 2 hydrogens. 2 oxygens, 2 oxygens. My dear students, that thing is not right. Isn't it? Here, when you add a 2 here, you are changing the compound. This one is no longer water. Now we have formed what we call hydrogen peroxide. Hydrogen peroxide. You have formed what we call hydrogen peroxide. It is now no longer water, meaning that we have changed the question. My dear students, I would like to tell you, or to add to you, that we don't tamper with numbers which are down here. These numbers, we call them subscripts. When you change a subscript, you are changing the equation. You are changing the formula. Whenever you are balancing an equation, never tamper with a subscript. Is it okay? Never add a number down here or remove a number down here, because when you do so, you are changing your equation. In this case, if a student had put a 2 here, meaning that he had changed the equation. In this case, he won't be getting water, but he'll be getting hydrogen peroxide. Therefore, my dear students, I add to you so that when you are balancing an equation, never tamper with subscripts. Is it okay? The subscripts, they don't change, or we don't add a number there. Reason being, when you add a number on the subscript, you are changing the formula. You are changing the product. You'll be doing another thing, not what they have given you to do. Is it okay? Yes. That's not the correct approach. Now, what I've been teaching you is balancing an equation in a visual way. This visual way can help us to understand what takes place in an equation. But let's do one example and we balance an equation without the visual way. Because when you're doing an exam, you may not need the visual way to balance an equation. You just need the other way to balance an equation. Is it okay? Let's look. Just pay attention and we see how we can balance this equation. Okay, take an example. If I have nitrogen plus hydrogen, these two, they combine to give me ammonia. And I want to balance that equation. Now in this equation here, we have, since we say we have the reactants and the products, we need to balance them. First and foremost, you need to first list down the number of atoms on both sides. In this case, we have nitrogen here, which is N. Also, we have hydrogen. On this side, we have also nitrogen, and also we have hydrogen. Since we have N2, meaning that we have 2 nitrogen atoms, we put it to here, and H2, meaning that we have 2 hydrogens, we put it to here. The same thing applies here. We have N, but we have 1 nitrogen, put a 1 here, and also H3, meaning that we have 3 hydrogens, we put a 3 here. If that's the case, we need to make sure that our equation is balanced. We need to play around and see how to balance this equation. Since we say it is a puzzle, you add numbers. What if, from here, you say, what if I add a 2 here? If I add a 2 here, that one, meaning that these 2 multiplies each and everything in that bracket. A 2 times 1, you get 2. This one changes to a 2. A 2 times a 3, it's a 6. Meaning that this one changes to a 6. If you are very critical enough, you are seeing that